Hi all. So we have gathered here to discuss topic quantum sensors. So you know that we are following design thinking based approach in our college. So we have 5 stages in design thinking, which is empathy, define, ideate, prototype, and test. So before going into that, you need to know what is quantum sensors. So they use quantum mechanics like entanglement and superposition to measure the physical properties like say gravity, field or time, etc. in a very extreme precise manner when compared to the classical methods. Okay, so they are used in applications like atomic clocks and very sensitive magnetometers like that. So I'll give you a few minutes to discuss among yourselves and then later we can share the points with each other. Okay, you can start your discussion. Okay, hope you have discussed among yourselves. So we can start to share the point. Who's going to start with the first stage, empathy part?
That is me, ma'am. I'm going to start with the empathy part. Actually, empathy part is discussing the problem of the person's being. So, how these sensors are used by different types of people, that is stakeholders. Here we take drivers, engineers, aerospace engineers, everybody use sensors in different manners. For example, let me give 3 major examples. That is the autonomous vehicles. The GPS of the autonomous vehicles fail in crowded areas. This is the first problem. The second problem is the industries. The industries fail to detect the fault. The third is the medical imaging systems. No, what they do is they do not detect the disease early. So these are the problems.
Yeah, sure. So next who's going to tell about the define part?
Myself. So I'll be discussing about the define part. So define part is how we are going to solve this problem with understanding the problems faced by the patients. And so we are designing a quantum magnetometer based wearable device which senses the ultra biosignals for diagnosing the cardiac diseases at an early stage. So as we are using this device in a human, we have to focus mainly on the design part. So the key technology constraint that we must focus is that our device must be can be used in a room temperature. Also, we can be able to integrate this AI into our device. Also, it must also have this IoT connectivity thing, and also it must consume only less power, and it must be low cost so that every patient can use it.
So next who's going to tell about the ideate part?
Myself going to discuss about the ideate and some of the quantum sensors and the application we use are NV diamond magnetometer, which is helps to the application is medical wearable, and atomic clock, which is used in smart grids, and cold atom accelerometer, which is used in GPS navigation, and quantum gravitometer is used in underground mapping, and also the last one is quantum image sensor, which is used in smart security. And some of the quantum devices that we can build is atomic AI enabled heart scanning wearable, and also quantum integrated navigation chip for smart wearable, and also for smart drones, and also quantum pollution detection for smart cities, and quantum brain signal helmet for neural monitoring.
Okay. Next, who's going to tell about the
So
prototype?
myself, I'm going to discuss about the prototype of the quantum sensor that we are going to build. So the system architecture of this quantum sensor that we are building in comes with the hardware layer, a software layer, and a digital image visualizing layer. So what is there in the hardware layer that we say is anything that hardware that we are going to use in our sensor comes under the hardware layer. So what are the hardware components that we are going to use in the sensor is the laser module, MEMS sensor that we commonly use, and other classical reference sensors, a battery, a power system that is going to power the sensor that we are going to build about. So what is the software layer and the component that we are going to use in here is a cloud dashboard, which is very essential because whatever the data that we are collecting, it should be and it is safe to upload it in a cloud, so we can access this anytime and anywhere.
Okay. Next, who's
So
going
I'll be discussing the testing part. In this testing part, we have 4 major steps that is to be followed. And the first one is that technical testing, and the next one is a smart system testing, followed by user testing, and at last compliance testing. In the smart system testing, we will be testing the mobile usability and reliability. And the user testing, we will be testing whether the calibration is done automatically or not, and whether we can deploy it, operators can deploy it in under 5 minutes or not, and whether the doctors can interpret the data properly or not. These are the things that we will be testing under the user testing, ma'am. And when it comes to compliance testing, we will be testing we will be ensuring the medical standards that is to be followed, and the space and defense regulations that is to be followed.
Yeah. So quantum sensors play a very vital role in all the applications. So it provides a breakthrough in the GPS navigations, in the medical imaging. It's also used in geology and fundamental science applications also. So here it mainly measures the changes in the quantum states caused by the external stimuli. So it provides very precise measurements. So the measurements are very stable, and it will not change over any time changes. Okay. So thank you all for sharing your points with each other.
Thank you, ma'am.
Thank you.